صداشون در
Hello, everyone. We are now on our final day of the workshop, and I hope everybody is doing great. Am I audible and visible? Just write in the chat box so that I know. Great. Thank you, Rita. Thank you, Rizwana. So anybody who's not on mute, I would request them to mute themselves. Okay. So as we all know that this is the final day of the workshop, and as much as I know, I'm not from a tech background, but as much as I know that you guys will be doing some exciting work today regarding running the code and all of that. And our instructor, Raima Islam, is here to guide you all through the process. But before we start, I would like to remind you all about the rules or the norms that we have. So please keep your videos turned on throughout the whole session. And please keep yourself muted. If you have any questions or concerns, obviously you have the chat.
We can probably give you a little extension when you explain what happened.
You will have the chat box for your questions and concerns. Other than that, we will keep ourselves muted because we have a lot of participants here. And if we all start speaking all at the same time, then it will be difficult for us to understand who's saying what and what's happening. So let's just respect the environment. And if you want to know more about HerWILL and what HerWILL is doing in the upcoming months or in the new year, get in touch with us in our social media platforms. You will be seeing a lot of the links going on in the comment box in a while. As usual, you have to fill up your attendance form and the feedback form. If you do not fill out these two forms, then it will be difficult for us to track who has completed all the workshops, and it will be difficult for us to provide you all with certificates that you all deserve if you have worked on this workshop so attentively. So without further ado, I would hand over the platform to Raima, and I would request the moderators to please check if we have the keeping everyone on mute option open, because I feel like that we don't have that yet. So yeah, I'm handing the right.
Hello, everyone. Welcome to the last session of your data science workshop. So today what we will be learning is the modeling part and also seeing results. So without further ado, let's start. Now, before we start the workshop, last class today, there are some theoretical things that you have to know. Bear with me. It's quite a lot of things, but it's definitely not that difficult. So let's start. So yesterday we learned about the NLP pre-processing techniques, where we learned how to clean the data, how to make the data ready for us to do the modeling. So today, now that we have done all the pre-steps, today we will be doing the main work. So let's start. So training and testing. So these are the two words that you will hear very, very commonly when you are doing any sort of data science or machine learning experiments. So what is this training and testing? So I have written an example in the slide, if you can see, but you don't have to read through the whole thing. I will explain it to you with a very easy to understand example. Suppose you learned a new sport, maybe soccer, maybe cricket, or rugby, any sort of sport. So what do? You first practice it by yourself or with people or with your team. Yes. So when you are practicing it, what do we call that phase? You are training for that sport that you have to play. So you have been training for a lot of days with a lot of teammates. So that is the process that is called training. And the testing is when you actually have to play the sport. The day of the sport, the day of the event, such as let me give you an example, maybe the World Cup. So can everyone please write in the chat box that which team do you support in FIFA World Cup? Maybe I can see. Like, I'm a supporter of actually, I don't really support any teams. Whenever someone asks me which team do you support in the World Cup, I just say the winning team. So last time it was no, I'm not a fan of Argentina, but I actually really like Brazil. Okay. Oh, we have a lot of Argentina fans here. Interesting. Brazil and Germany, the number one team, Argentina. That's good. That's good. Yes, of course they're number one. They have Messi after all. So how did Argentina even win the World Cup? Of course, they trained. They had the best strategies. They they worked harder than most people. So they had Lionel Messi. But before they came to the World Cup, before they played the final, what did they do? They trained for a very long period by trying out different tactics, by training day and night, so that on the day of the test, which is the final day, the final match against France, it was against France, right? I don't remember, sorry. So the way that they trained, the way that they have practiced different strategies, that is what led them to perform their best and win the World Cup on the test day. So in machine learning, it's the same, training and testing. So now we have data. So what they will do is first, we will feed it a certain amount of data to it so that the model can learn the patterns, the techniques, the insights from the data. And on the testing, what they will do, we will give them data that they have never seen for the model. The model has never seen the data. So from whatever patterns that they have learned from the training data, the model will try to apply it on the testing data. I mean, the final World Cup, does it happen twice? No, it happens once, the final match. So before the final match happens, Argentina has given their all in the training phase so that when they are faced with an unknown territory or unknown team, such as France, Argentina doesn't know what France is going to do. But the fact that they have trained so much, they have learned the patterns, they have learned the techniques, they can tackle with France and play as good as they did. So machine learning works the same way. So it's not very different from how we operate in our real lives, even though it's a technical term, but the concepts and the ideas, they all come from the way we live our lives. So that is basically what training and testing is. Okay, so let's go to our file. I would tell everyone to go to runtime and just press on run all. It is very important that you have ran all the cells, because trust me, you can write thousands and thousands of lines, but if you forget to run one cell, your entire code base is going to break down. So that is one thing that you have to learn about the world of coding, that every single part of your code has to work, even if you have 0.1% of mistake, it's gonna totally break down. So make sure that you are going to runtime and you are pressing on run all. So if you guys have done running the run all part, so just go to runtime and click on run all. If you guys are done, let me know. I think it's gonna take some time because the porter stemmer, the tokenize, probably altogether it's gonna take like 3 to 4 minutes. Erica is done. Okay. So I am actually sharing the collab file with you guys, which has the day 3 code, just in case you guys can follow me along. But this is just for people who cannot follow along, so I would not recommend any of you guys to just blindly copy and paste, because you guys are spending so much time and of your day to come and attend the workshop. So make sure you're learning what you're doing. Here you go. It contains all the codes of day 3. So just in case you can follow along, you can just copy and paste it from here. Okay. So now I would tell everyone to go to day 3. So day 3, now we will be doing the train and test splitting. So in machine learning or data science, what we usually do is we try to split the data. The same data, some part of the data will go for training and some part of the data will go for testing. So how much do we want to split? It depends on us and our context. So usually it's 80% of the data goes for training and 20% goes for testing. But that is not the hard and fast rule that you must follow. As I have mentioned, it depends on the context. That maybe when you have a small subset of data, now we have a pretty big data where it's like 50,000 entries, but that won't be the case. Or maybe at times you will have like 3 times more the data. So how you split it, it depends on you. And as I have said, you have to experiment it a lot to see that what sort of splitting is giving the optimal result. So let's start. I have already written the code here, but I will write it again and explain it step by step. So what we will do is we will split the data into train and testing. So let's write train underscore reviews. Guys, as I have mentioned, it's very important to make sure you are giving meaningful names to your variables. So data.review. Data.review basically means the name of the column inside the data file. So we are taking the review column, and what I will do is I will use square bracket and just write colon 40,000. So what did I just do here? This basically means that from the start of the data till the 40,000 data, this will be our training data for our review column. So from the start of the data till the 40,000 row, that will consist our training data, okay? And test review, as I have written, it will be from the 40,000 till the last data we have, which is the 50,000. So 40,000 data goes for training and 10,000 data goes for testing. So this goes for the review column. And now we do the same for the sentiment column as well. Now you have to make sure that when you are splitting the data for the columns that you have, so again, we are checking what the sentiment of the review is. So you have to make sure that the splitting of both the columns, it must be equal. Not like you chose 40,000 here for training and 10,000 for testing. For the review column, for sentiment, you have to make sure it's exactly the same as well. Because if you don't, it's going to give you, first of all, errors and an incorrect distribution and incorrect results as well. So you have to make sure that all of them are the same, the distribution that you do for each column. So here I did exactly the same as well. So for the sentiment column, the training sentiment equals to data.sentiment, which basically means the data file's sentiment column. So till the 40,000 data, we are sending it to the training set. And for the testing set, from 48,000 till the last part of the data, this is will go to the testing set. So if you guys are done, you guys can run it and see. So if you guys are done running, let me know. Okay. Now comes count vectorizer. So what I have been mentioning till now, that yes, we can read data as it is. It's written in English, we can read it and understand what's going on. But does our computer or does our model understand English? No, it doesn't. It only understands numbers. So as I have mentioned, to make the data ready for us to send it to our model, it is very essential to ensure that our data has been pre-processed in certain ways. So there comes count vectorizer to turn our words into certain counts. So how does count vectorizer work? It's a bit theoretical, so please pay attention. So suppose you have some sentences, a collection of sentences, such as I love pizza, pizza is delicious, I enjoy eating pizza. So count vectorizer is sort of like a process which turns these sentences into numbers for the computer to understand that what we are sending. Because like I said, we humans might understand English, but computer does not understand English. It only understands numbers. So what do is we create a dictionary first. So what we do is for the dictionary, we only take the unique words in our collection. So let's do it. I love pizza. Okay, three of them are unique. Pizza is delicious. In this second sentence, only is and delicious will go to the dictionary. Yes, to the vocabulary because pizza is not unique. Pizza already appeared in the first sentence. So the vocabulary now contains I love pizza is delicious. Now let's go to the next line. I enjoy eating pizza. I will not go into the vocabulary because it already appeared in the first sentence. Enjoy will go, eating will go, pizza will also not go because pizza was also in the second sentence and also in the first sentence. So only the unique words, they will go to the vocabulary. So now we have created the vocabulary with only the unique words. What we will do is we will take the count that how many times these words are appearing in the sentence. So that is what I did. That in sentence, so we have all the unique words which we are putting it column wise. And in the rows, it's the number of sentences that we have. Sentence 1, sentence 2, sentence 3. So here you can see numbers that I love in sentence 1, which words are appearing. So let's go back again. I love pizza. So in sentence 1, I love pizza is appearing. So that's why 1, 1, a score of 1, a score of 1, a score of 1 is given, and the rest is 0 because these are not appearing in the first sentence. So in the second sentence, let's go back. Pizza is delicious. So in the second sentence, what are appearing? Pizza is delicious. Since the others are not appearing, so we're giving it a 0. And I enjoy eating pizza. So in sentence 3, I enjoy eating pizza. So since these are the words that are appearing, delicious is not appearing, is not appearing, love is not appearing, so we're giving it a 0. That is how count vectorizer works. Now you must be wondering that, oh my God, so many processes. Do I have to write 1000 lines of code? Of course not. That is the beauty of importing libraries. Because in the libraries, everything is already been coded. We just have to call the certain names. That's it. So this is basically what count vectorizer is. So, and this is the code. So that is what you have to write. Let me just send it to you. So CV, which stands for count vectorizer, and we are calling the count vectorizer function where we have to set some numbers where if it appears, we're giving it 1, and if it doesn't appear, we're giving it 0. That's why mean and max is given. And binary value, we're giving it false, and n-gram range 1 to 3. These are not some things that you have to know explicitly. Just know that these are the functions that you must define in order to make the count vectorizer work. So if you guys are done, let me know. Farhin Siddiq, no, it won't be considered two different. Yes, it will be actually considered two different words because pizza and pizzas, they're not the same thing. They don't mean the same thing. Pizza means one slice of pizza, and pizzas, it means that it can be more than one. So the meanings are different. That's why they will be considered different words. It's a good thing that you pointed it out. And I think someone asked what is engram. So engram is basically a sequence of n number of words. N stands for the number of words. Suppose how many words that we wanted to consider. So since we have given 1 to 3, so it will consider the number that falls in that category. So 1 to 3 basically means it goes to the trigram or the 3-gram modeling method. But if I start to go on and on about it, I think you guys will just get confused. So what all you have to know is that it means that it is just the sequence of words that it is considering for now. Yes, for stemming, we actually took its root form, but so now everything is pizza. But since this is an example that I'm showing you for now, that's why I have considered the same word again. And since someone had a question that whether pizzas and pizza would be considered different words, yes, they would be considered different words. But since we did stemming, pizzas became pizza. So I can see that you guys are also catching up on the theories very well as well. So that's actually very amazing. Therefore, if the count vectorizer part is done, let us do fit transform. Now, fit transform is also it's not exactly complicated, but you have to pay a bit of attention to understand it fully. So, okay, suppose you were given a robot and you have to teach the robot that you have to recognize fruits from now on. So what do? You take a bunch of apples and oranges and you tell the robot that, hey, I have apples and oranges. So what the robot does, that robots don't have the innate or the inherent ability to learn something just by looking at it. We have to teach it to them. We have to feed the information by ourselves. So what the robot will do is it will try to learn the pattern, the texture, the shape, the color, and everything of the fruits that we have given. So in machine learning, the robot actually acts like the model, and the apples and oranges are our training data. Now, let's go back to the theory that I have taught you, that what training and testing means. Now, in the testing phase, we have to make sure that our robot can recognize, is it possible? So what our robot needs to do is identify new sort of fruits which it has never seen. For example, it has only seen orange and apple, but let's take an example of another um, fruit which has similar shape, uh, such as a plum, or not exactly similar shape, but another bumpy sort of textured strawberry. So now I tell my robot, hey, can you identify which fruits these are? So that is what our robot has to accomplish, that it has never seen the data, but it has to recognize that what sort of fruit or item that this is. So fit, transform, and transform. So in fit transform, the model will learn exactly what we have given it to them. For example, apple and orange, it will learn each and every single pattern, each and every single thing there is to learn about apples and oranges. And in the transform, what it will do is when it will see a new item, suppose I give it a plum. So what it will do is it will try to apply the same techniques it has learned when I gave it to learn about apples and oranges, and try to see which characteristics match, which don't. And with that, it has to recognize which fruit it is. So fit transform, what it exactly stands for, it will exactly fit to the data that we are giving it. And transform, what it will do is whatever the model has learned during the training phase, it will try to transform our unseen data into the patterns it has learned during the testing data. Basically, the patterns and textures and techniques and everything it has learned while learning about apples and oranges, when I give it a plum, it will try to apply whatever it has learned about apples and oranges to try to identify what sort of fruit it is, whether it's a plum, whether I again gave it an orange or an apple. So that is what fit, transform, and transform means. So we use fit transform when it comes to training data and transform when it comes to testing data. So you can write it. Let me write it again and send it to you guys. It will actually take it the first 1 to 40,000 data that is there. So it will be sequential. Since we haven't applied any sort of randomizer to it, there is code to apply randomizer. So, but since we haven't applied it now, to shuffle the data, it will take the sequential one. And for the test, the data. This is actually a good point that you have pointed out, Rakib, because this data is already in a shuffled state, so that's why we could take it in a so that's why we could take the sequential splitting, but there will be cases that the shuffling is not done. So you could see that first 25,000 data is only positive and the last 25,000 data is negative, and you do the same sort of splitting that we did. So all your data has is more positive data than negative data. So when you apply the model, it will give you inaccurate predictions because it has only seen the positive reviews. It has not seen the negative reviews. Erica, so after the day 2, step 3, can you apply this? Like after Porter stemmer, can you write this data line? Because if you don't do it, it's not gonna work. Like after the Porter stemmer thing we did, after that, I write this line where we are joining all the data to create a sort of list. If you run this, it should work. For which one? This one? Yes, so if you're getting that error, what you have to do is after you have written the Porter and stemmer pre-processing code, just add this code. After you have done adding this code, I have shared it in the chat. Let me share it again. What you will do is just run these things again. And run them again. It should work. Okay, let me add the code. In the file that I have shared, so that you guys can copy. So if you go to the day 3 code, I have added another code. In the first cell, you can see that I have added a code where we join all the pre-processing that we did into a list. Okay, Erica's code worked, so I'm hoping for others it will start working as well. So if I get a few more yeses, if it worked or not, I will move on. Okay, that's good to know. So what you guys have to do is, when you go to the day 2 code, after the porter and stemmer, when you give this code to run it, and you have to run these again, because now it will be splitted on the basis of a list. So make sure that you are running these again before running the count vectorizer, or else you're gonna get the same errors. And the count vectorizer fit transforming will take some time. It took me like 45 seconds. So guys, make sure the code that I have written here, make sure you ran this and you are running these again, or else you're gonna keep getting the error. It's important to run the code in a sequential manner. Did you run all the train test splitting data again? Like you also have to run this and this and this. All right, let's start here. Let's start from here again. So what you have to do is you have to first run this cell, okay? After you run this cell, what you're gonna do is come to day 3 and then run this, then run this, run this, and this, like the train review splitting, the test review splitting, then the train sentiment splitting, and the test sentiment splitting. After that, what you have to do is you have to run this, the count vectorizer which we have initialized, and then the fit transform will work. If you think like your code is not working, maybe you have to like click on restart session and run the codes from the very beginning again, or just give run all. I would suggest that you restart the session, because if you're not running the code cells sequentially, you'll keep getting the same error. So I would say restart the session and then click on run all. All right, for the ones whose codes are working, what you do is you write this code now, where you transform the test reviews for the training data sequence and patterns to be applied to the test reviews here. So for the ones whose code is not working, I would suggest that you click on restart session, and then after the session has restarted, click on run all. Let's see if I can show it to you. Like I'll just click on save a copy in Drive again. I don't think it will allow me because I'm using the free version of Collab, so I don't think it's gonna let me simultaneously run it. But all you have to do is just click restart session and click on run all. So it should work after that. So for the ones whose code is working, what you have to do is now do the same thing for the test reviews. And for this, you will only use transform, not fit transform, because fit transform is only for the training data. For the testing data, it will just learn the patterns of the training data that we have given it. So if you guys are done, let me know. All right. Ornov, did you write the new line that I have added in the day three code that I have showed? Because if you're still getting the error, I would suggest you to restart the runtime and then click on run all. Because sometimes when you are running the cells without going sequentially, it can cause problems. It won't be a problem when you do it in actual environments such as VS Code. But since we're using a free version provided by Google, we have to keep some things in mind where some things need to be done sequentially. So if you guys are done with this step of transforming the test reviews, let me know. If you guys are done, then I will move to label binarizer. So somebody asked me that whether we should do the same fit transform for our sentiment column as well. We actually won't be doing that because let's not make our lives difficult, since these are what should I say, the sentiment column, we only have two values, positive and negative. So after giving that positive and negative labels, what we have to do is just give it a number, 0 or 1, as I have mentioned that our computer can only understand numbers, it doesn't understand words. So uh, since we only have two words here, let's just use a binarizer to turn it into 0 and 1, because we don't have an huge assortment of words or huge sentences where we have to categorize each word to each number. It's fairly simple. So that is what label binarizer accomplishes. So for this, I have given an example that we have to suppose you are given a data where you have to find that which ones are apples and which ones are not. So your data might look like you have a lot of different sort of fruits, such as apple, banana, orange, and banana. So what you have to do is, after using label binarizer, the ones which has apple, it will become 1, and the other fruits which are not apple, it will become 0. So that our model is ready for training and testing, that is what we will be using here. So just initialize the label binarizer. So just write it LB equals to label binarizer and the function here, so that you call the label binarizer function to change our sentiment column. And for the sentiment, yes, we will be using the fit transform for both of our training and testing here, because while we are not using the same method, but here the fit transform is actually applicable for both, because what we are doing is that uh, while the training and testing data, they have the same sort of values, positive and negatives, we will be testing it against the sentiment column. So we are trying to predict the sentiment here. So we're not trying to predict the review here. We will be feeding it and review. And our model, what it will do is try to find out what the sentiment is, whether it is positive or negative. So what you're going to do is then transform the training and testing sentiments into binary numbers. this shouldn't take too much time if your previous codes are working fine. Okay, great. Now comes the part that we have all been waiting for, is that now we will try the modeling. So, Arnav, it's great. Your issue has been resolved. As I have mentioned, that if you are getting the value errors or execution error, runtime error, whichever error you're getting, only way it will be solved is that you have to click on restart session and click on run all. If you don't do this, your issue will go on. So make sure that you're restarting the session and clicking on run all. So let's learn which machine learning model we will be using. So this is the step, and if you can apply it, you'll be able to call yourself scientists. So be ready to become scientists in the next 10 to 15 minutes. Joe Baida, are you following the code that I have given? So before, there is one line of code that you have to write, where if you don't write it, the error is going to keep happening. So this is the line. I hope you added it. You have to add this code, which I have given in the chat, after the Porter stemmer part. And if it is, have you done the restart thing? Okay. Then that's weird, because I have to see your code by myself individually where it is giving the error. But don't worry about that. After this session ends, I will be sharing the entire code from day 1 to day 2 in one file, so that you guys will be able to see where you made the mistakes, or if there was anything that you want to know, or in one place basically. So don't worry, everything will be shared with you guys. So multinomial naive Bayes. Has anyone worked with naive Bayes before? Can I get some yes or no's? Most of you guys are saying no, which is fine. And one person wanted to know, can we have a short overview of ML models, when to use what? Yes, maybe at the end of the session, I can give you a small overview of what sort of ML models we can use. So since multinomial naive Bayes, yes, numerical methods, exactly. It is a very, very technical mathematical concept. And in this session, we have people joining from very, very various backgrounds. So that's why I have opted out of explaining it in a very theoretical or technical way, because it is very important that everyone in this session understands that what multinomial naive Bayes is. So I will be using very generic examples. And if you guys want the technical bits of how these things work, I have also compiled articles for these. So if you guys are interested, you guys can let me know at the end of the session that you also want to learn the theory. So I will be sending you guys a list of the theoretical things you have to learn as well. So suppose, again, the training and testing, let's bring it here. So that is what we have been talking about since the beginning of the session, training and testing, training and testing. So now you have another task to do, that you yourself, you're a robot, and I have, so uh, can somebody from the team help Nishat about the attendance forms? So what we do is, for the training and testing, that you have been given a task to sort your emails into work, personal, and spam. So we get a lot of emails all the time. Sometimes so many promotional emails, work emails, scam emails where they send you that you have just won $50,000, and if you click on it, all your accounts will get hacked. So all sorts of emails we get. So as a robot, I'm telling you that, hey robot, can you classify my emails into three categories: work, personal, and spam? So during the learning phase, what our robot will do is it will look at all our past emails which have been categorized already. If you use Gmail, you can see that the emails have been categorized into different categories, such as promotional emails, spam, junk, inbox. So by the data that it has already seen, it will learn the patterns, that this is how I should be classifying the emails. That uh, emails that say that you have won $50,000, go to spam. Email from my workplace, hey, Raima, I need the training deck by 5 p.m. today. So it goes to work email. And personal emails, your friend sends you an email that, hey, Raima, let's meet up at this time tomorrow. So it will go to personal. So the robot will learn the pattern of how my emails are and it will categorize it. And in the testing phase, when it sees a new sort of email, such as example, promotional email, that suppose Spotify has given you a promotional email that, hey, Raima, you have been using our uh, product or our app for so many years. Here is a small discount as a token of appreciation from us. So promotional email when we send it to it. So now what our robot will do is try to categorize that which sort of category does it fall under, and which is what is the most likelihood. Since while it is a promotional email, uh, and since we don't have the category promotion here, it is only work, personal, and spam. What our model will do is it will calculate the probability that what is the highest chance or likelihood that this email can fall under. So what it will do is it will try to do its own modeling, its own calculations, and try to find the probabilities, which one has the highest chance of the email going under work, personal, or spam. So here are some key concepts. What is the naive assumption? The robot makes a naive assumption that the occurrence of each word is independent of the occurrence of other words. It is, okay, a lot of technical details here, is that each word in the email, it's like, I'm going a bit into mathematics. It's that it is not dependent on what the other word says. So each word is its own identity. And the word multinomial means it is looking at the count of words in each category. How many words each word appears in the, okay. And the multinomial, what it does is, in the different categories, it is counting that in the work category, what is the average number of words, in the personal, what is the average number of words, and in the spam, what is the average number of words. So here I have given an example that the robot learns the word project, which appears very frequently in work emails, and family appears in the personal emails, and free appears in the spam emails. Now, when you get a new email which contains the word project, family, and free, the robot will calculate the likelihood of what it has learned previously. So when it sees the word project, it will likely be in the work folder. So if it gets the word family in the email, it will do the calculations and try to understand that whether it falls under the personal email. And if it sees the word free, it will try to go to the spam email. So in multinomial naive Bayes, it applies the Bayes theorem to make the calculations of the likelihood of that email falling under a certain category. So suppose you get the word project. The robot gets then an email with the word project in it. Now what it will do, it will calculate the probability that in work, it has a probability of being a work email by 90%. In personal email, it has the probability of being in 50%, and in personal and in spam, it has the probability of being it in 10%. So that is what it is doing. It uses the Bayes theorem to calculate what is the probability of that certain email to fall under the work category if it sees the word project. So it does that sort of categorization and sorting. So let's apply that model. I think I have talked way too much about the theory. Let's not boggle our minds. So here I have called the multinomial naive Bayes function, where you don't have to write the whole word. That's why I have stored it in a variable called mnb. And what we are doing here is we are fitting the model. So when we are fitting the model, we are calling the dot fit function. So after calling the dot fit function, what we are doing is we're giving the count vectorized reviews and the label binarized sentiments, so that the reviews are trained against the sentiments. So this is the line that you have to write. Shouldn't take, when you run it, it shouldn't take much time. So if you guys are done till now, let me know. Okay. Now, what we are going to do is we are going to predict it, that with the test data, what sort of model it is giving us. Modeling it is giving us. So you guys are getting errors. What sort of error are you guys getting? Value error. Till this step, is everything working? Because if these ones are not properly ran, or if you're getting error here, the steps that I have shown just now will not work. So are these parts working before step 3? I think the fact that some of you guys have like changed the numbers here, so maybe that's why it's not working. So make sure these are the numbers that you're using. And also make sure that the review and sentiment are properly labeled. Yes, exactly. These are trained sentiment, guys. You cannot use data.review here. It's for the sentiment column. And make sure that these numbers match exactly, or else it's gonna give errors. That's what I have been mentioning since day one, that coding is actually a very, very delicate process. I think you guys are understanding very well today that one simple mistake of numbers is gonna destroy the entire code that you have very worked hard for and writing for the past 2 days. So make sure that everything is like to the point and you guys are following each and every single step that I'm showing. If you guys are getting the error, I would suggest you guys to follow the code that I have given. I'm sending it here again. Make sure that the train_sentiment says data.sentiment, not data.review, as we are splitting the sentiment data here. I think this is where everyone is getting the common mistake from. Okay, for Nilima, it worked. So if it worked for you guys, let me know. We will go to the modeling part. Great, great. Okay, so now the prediction part. So for the test data, we will be predicting what the labels are. So can someone please tell me that for predicting, why haven't we added the test labels here? Why did we only add the reviews? Any short answer in the text would work. Like, this is what I have been discussing since the beginning of the session today, that why for the test data, it's important to work on unseen data. So what I'm asking is that here, see that for the training data, when we are fitting the data, is what we're doing is we're adding the sentiment labels. But for testing it, we're not adding the sentiment labels. Why is that? To check the model performance on the unseen data. Exactly. Well done. Yes. Yes, it is going to generate binarized sentiments for us, but what will happen? What will we check after it gives us the binarized sentiments? Accuracy, yes, we will be eventually finding the accuracy, but what other thing is important to check here? All of you guys are right in a sense, but whether, yes, Erica, you're right. Is the model giving correct label? Yes. So most of you guys have gotten the answer right, is that we are not giving the test sentiment labels to the test data because our model has not seen the test data. So to understand how our model is performing on the test data, it is important that we understand that whether it is giving us the correct sentiment or not. So most of you guys have hit the nail in the coffin. Okay. So now that you have gotten this part correct, let us try to find the accuracy. So for this, we will be using the accuracy score function, where it will calculate the accuracy. So for the accuracy formula, you can look it up online and see how it is done. So it takes the true positives and the true negatives, but I will not be going to the too much details onto it because it's not needed for you guys right now. But if you want to learn it on your own, you can. So in the function, what we are passing the actual sentiment labels that we have and what our model has predicted. So it will see that what our model has predicted, is it same as what the actual labels are. So when we print the accuracy, we will be getting a score. So try to write this and tell me what accuracy you guys get. I think everyone more or less is going to get the same accuracy. So let me know what accuracy you guys get. So everyone is getting 0.7425%. Okay. So more or less everyone is getting the same one. So well done. Some of you guys are getting value error. Did you guys like properly write this part, or else you guys are gonna get some sort of value error? Or if someone got like 50%, I think, I don't know, maybe the pre-processing step, your GPU couldn't handle it properly, or maybe can you see if you missed a step? Because it should be between 70 to 75%. But if it's not, don't worry about it. There are many, many ways to increase the accuracy. So if you guys have gotten the accuracy, so I haven't converted it into percentage, but if you guys want to get it in percentage, like just you have to multiply it by 100. And if it's done, it's basically 74.25%, which is not great, but not bad either. Because first of all, we have a wide range of data, and to handle everything, the level of pre-processing that we have to do, and since so many words are involved here, it is important that we apply a lot of techniques, a lot of ways, so that our data is completely ready. Since this is just a beginner level course and we have so many restrictions when it comes to time, the resources we have, so that's why we had to cut it down a lot on the things that we show. But it is very much possible to bring the accuracy to above 90%, even 98, 99% as well. But this is considered a good accuracy, not the greatest, but good. So now that you have gotten the accuracy, you're more or less done with building the model. So people who have gotten some sort of accuracy, congratulations, you are 99% done with the workshop. And the ones who are getting errors and everything, I will be sharing this entire file with you guys so that you guys can see and understand that where it is wrong. And what I will suggest is, from most of the errors that I am seeing, is that you have to probably run the codes sequentially one by one, not randomly, and make sure that all the words and all the parameters are correct. Because if these are not correct, as I have mentioned, that you will keep getting errors. So now we will come to the final step, which is word cloud. So word cloud is basically, okay, can someone please tell me if you have seen this sort of visualization before? in social media, or if you have experience with these sort of things. Okay, so you guys know what already word cloud is. So word cloud basically gives us the it basically gives us all the common words that we are seeing in our data. So what you have to do is, yes, exactly, most used words are emphasized. So what you have to do is, this is some code that I have written, but this is not something that you have to memorize or understand. So what you have to do is just copy paste the code and just put it to see which are the most positive words that you are seeing in the reviews. So the code is already given in the file that I have shared. So you can just copy paste and see. So if you guys want an explanation, I will give it to you. From here, we have just imported the word cloud library and the pyplot lib, which is another library to see visualizations. And what we have done here is we have joined all the positive words in the review by checking it against the positive sentiment, that only if the sentiment is positive, we will be getting the positive words from the review. So we have joined those words and we have used some numbers, that what the width will be, what the height will be. Random state is just shuffling the words that we have and generate the word cloud. And these are just some numbers which we can use to see how big we want the figure. That's about it. Worked. Okay, great. So let me know if you guys can see the number of all the most used positive words. How about the others? Did the code work for you guys? Are you guys seeing the visual representation of the positive words? Yes, if you want to see the negative words, just change the positive to negative. That's it. I think, yes, just change it as data sentiment equals to negative, and you will get the negative words. Okay, since most of you guys are writing, it has worked. So all I will say right now is congratulations to all of you here. You have officially completed the workshop. You have officially completed the project from day 1 to day 3. You have done all the steps, from loading the data, from importing the libraries, from applying natural language processing level techniques, and uh, doing the modeling, getting the accuracy, and also finding the word cloud. So congratulations to everyone. A big round of applause to all of you. So you should definitely clap for yourselves as well and pat yourselves in the back, because this was not easy at all. I'm pretty sure that most of you guys got the real taste of coding today, because everyone was getting errors. Some steps were not working. So what I will say is that yes, there will be times, most of the time your code will work, but when you are actually working as a data scientist, most of the times your code will not work. And unfortunately, that's the harsh reality of it. But I would say that's actually the fun of it. If you guys did not face the errors that you faced today, you guys wouldn't have learned that, why am I getting this error? How do I solve it? So it's very important to make mistakes as well. But just because you're making mistakes, that doesn't mean that you are getting behind. It just means you're getting very much ahead of everyone. Because unless you learn from your mistakes, you're actually not learning. So therefore, my suggestion to you guys will be that definitely add this project to your CV and try to upload it on GitHub as well, because that way your recruiters can also see that this is the project that you have done, because there needs to be some sort of proof that I completed this project. So it's important to increase the visibility. And all I will say is that from the comments that I have been getting, the feedback, most of you guys were hoping that you were getting a bit more introduction into coding. But since this workshop is mostly focused on data science, so if you guys want some other workshops in some other time that you guys want to learn coding from scratch, not data science, just coding, you should definitely let us know that we want an intro to coding course as well. Or if you guys want advanced level or how to crack data science interviews, let us know, because your feedbacks are actually very, very valuable to us, because we also need to understand that what our participants want as well. We have to make sure that we are catering to your needs. And before I finish my long speech, I want to say congratulations to all of you again. And don't forget, from the 16th December, our data science contest is starting. So it will basically be on whatever that we have taught you. Of course, it won't be the same, but you should definitely participate, because we have loads and loads of exciting prizes for you guys. We have judges joining us from the United States, from some of the best universities there. So you will get a chance to network with them. We have scholarships for you guys from Google. And we have other lots of exciting prizes as well from NSDC. You guys will be recognized from NSDC, as I have mentioned, that it is an organization of an Ivy League university. So these recognitions are very, very important for you guys to stand out from the rest. So definitely, guys, participate in that contest and make sure you're getting the certificates and the scholarships. And that's all. I'll leave you be. Congratulations once again. Hope you guys keep practicing, and we will be sending you guys the certificates very soon. So Tahia, I'll let you take over. It will be an individual contest.
Thank you so much. Thank you so much, everyone, for taking your time and completing the 3 days workshop. And I hope that this was a new and very unique learning experience for you all, because we have seen that a lot of you are not from the engineering background, and I am also not from engineering background. So when I see Raima doing this amazing workshop and you guys doing this code so swiftly, I felt like a total somebody who's lost in the process, like what is happening and what's going on. But seeing all of you guys take Raima's instructions and details so precisely and applying those and working those to get the results that you have gotten, it has made me realize that probably the workshops have really worked for you all. So I would again request, as Rama already mentioned, that I would again request all of you to complete filling out the feedback form and the attendance form. I would request the interns to share the forms once more in the chat box for those who have not yet filled it out, because that's very important. And yes, so our datathon contest is going to be starting from 16th December, and you will be getting, a separate email regarding that in the coming days. Regarding the certification, please bear with us because we have to probably take like 2 or 3 days to process that. Also, we may also give you the certification after the datathon as well. Whatever we do, we are going to notify you via email. The email address is the same one, leadership@herwill.org. So keep an eye on your email for further updates and stay connected to HerWill. If you guys want to work with us, be associated with us, volunteer for us, you can check our social media links and get in touch with us again via email as well. So all the best and congratulations to you, Raima, for pulling it off. You have done a wonderful job, and great to see you guys being so interactive and so willing to learn something that probably was very new for a lot of you. Before signing off, I would request Mukatsa to take a group photo of all of us, and I would request all of you to come on camera and pose and smile and say cheese and do whatever you want to do, but show a smiley face so that we can show the world that this was a really wonderful workshop and you guys liked it. So, okay, I'll just go ahead. Mukatsa, I'll hand the floor over to you. Once you're done taking the photo, you can
Maybe
just close.
can you guys come up with something like this or like a reaction or something, and I'll go ahead. Then maybe stay in that pose for like 3-4 seconds, and I'll be, taking the pictures. Thank you. Perfect. I'm done. Thank you.
Thank you, everyone. You guys can take your leave now if you are done with filling out the forms, and we will be closing the room in like 3 or 4 minutes. So thank you once again. Looking forward to seeing all of you in the datathon.